Okay, Assalamualaikum and very good morning. Today we will continue with our next lecture, which is on the title of 2D and 3D coordinate transformations. This is lecture number 7. Okay, on the theoretical part is the final lecture. Okay, so Dr. Chang already covered 5 topics, including the introduction. Now I will cover the next 2 topics, and this is the last one. Okay, so okay, so for this topic, okay, what is transformations? Okay, transformation are actually the fundamental in computer graphics. Okay, any of the whatever we do in the 2D and 3D drawings, okay, is basically involve a transformation. Okay, so this is some of the important things that you know in terms of transformation. The first thing on the positioning the objects, okay, maybe you want to move the object from point A to point B, okay. And another one is on the shaping the objects, okay. For example, you want to make an object bigger, and or you want to change the object from big to small object, okay. So this involve a shaping of the objects, change of view positions, okay. As what you already done before in SolidWorks, there's a view in terms of top view, okay, front view, side view, okay, and also change the perspective, okay, how the something can be viewed, okay, is it more view in clearer in the front view, or maybe it's more clear to view in a isometric view, okay. There is something of important things that you have to know, okay. So basically for the transformation, okay, there's involved of 4 basic step, okay. The first step is on the translation, okay, where it's just basically a basic one. When you want to move from point A to point B, this involve a translation. The scaling, okay, you want to make the objects bigger or smaller, okay, involve scaling. Rotation, okay, you want to rotate the 3D drawing or 2D 3D drawing of your products, okay, or designs, okay. And shearing, okay, shearing is involve 2 movement like x and y axis movement in the same time, okay. This is mostly involve some when you do some of simulation that is involve some shearing movement, okay. So there's also the equation that involve in the background of the shearing movement, okay. So for this one, okay, they can be combined to obtain a more complex transformation, okay. It can be combined of all 4 transformation together, okay. Let's see how. And then it can be assumed this is homogeneous coordinate, okay, for the projective geometry where it's a from the origin coordinate lah, which is 0 0 basically. Okay, so representation of point or objects, okay. A point in 2D is represented by a coordinate of xy, is the basic. I think most of you know. When we come to the 2D, 2 dimensions, it's just involve of 2 axes of x and y, okay. An object is represented as a set of points, okay, and associate set of edge, okay, where x is defined as a pair of the points. Okay, so this is an example. You have 3 points, A, point B, and point C. So from B to C is we call it edge, okay, A to B, okay, or A to C, okay. So basically the 2D and 3D transformation are in the same in concept basically, but 2D is more simple, okay. So the explanation for this for today lecture will mostly be done in the 2D lah, okay. This is just a different of just additional of one more axis, z axis for the 3D, okay. Okay, so what you will learn today, the first thing is on the 2D transformation, okay, basic 2D transformation and also metric representations, okay, and the another thing is on the 3D transformation, which is basic 3D transformation and also the metric representation, which is basically similar to the 2D. Okay, so for the basic metric algebra, okay, you can get this one of the example in terms of uh, translation, okay, and basic metric multiplication is involved 2 multiplied by 2 matrix multiplied by 2 multiplied by 1 matrix, okay. So this is, for example, in terms of result you will get, okay, 2 multiplied by 1 matrix, okay. So this you have 2, okay, 2 2 by 2 matrix, and this one is 2 by 1, okay. Okay, in terms of uh, columns and rows, okay, you can know it 2 by 2 or 2 by 1, and the result will be 2 multiplied by 1, like this, okay, the x dash and y dash, okay. So it involve all use the same concept where there is a 3 elements, the origin position, okay, the xy coordinate that's given, the operations, okay, is it a translation, scaling, okay, rotation or sharing, and finally the resulting position, the x dash and y dash. So if it involve a 3D, is have x, y and z direction. So for this matrix is a basic, okay, formulation when you get the x dash, a multiplied by x, okay, plus b multiplied by y. So the same method, y dash, okay, c multiplied by x plus d multiplied by y, okay. This is you have they learn in calculus basically. Okay, so the next one, okay, is on the 2D translation, okay, the first transformation, okay, where we want to move the point x direction by dx, okay, and move the y point y by dy, okay. This is a very simple and straightforward, okay, where you have the origin coordinate xy and you have a translation uh, value, okay, you just add directly lah, okay, and you will get the x dash and y dash coordinate, okay. This is the equation number 1 that you have to remember, okay. Beware during the test, we will not provide you the equation because it's a very simple equation, so you need to remember, okay. So this is in terms of metric representation, okay, where you have a origin, the operation, okay, and you directly uh, add, okay, do the summation, and then you will get the results. This is similar to the equation, okay. Okay, so the 2D translation matrix is the represent of 2D coordinate using a 3 vectors, okay. So basically it also can be shown in terms of where is a scaling factors, okay. X, Y and W is represent as a scale factors, okay. So for example, this coordinate, okay, the origin 6, 3, 1, okay, when it's scaled by 2, is all element is multiplied by 2, okay, 6 multiplied by 2, 12, 3 multiplied by 2, 6, and 1 multiplied by 2 is 2, okay. So basically if we involve a translation only, we can just set a scale factor is 1 lah, unless you involve the two of the combination transformation, translation and scaling, then we can use a scale factor of 2, 3 and so on, okay. For this basic one, so just a scaling of 1, so x dash, okay, so y dash, the results, okay, this is the original coordinate xy, okay, is just directly additional, okay, x plus dx or y plus dy, or we can also refer to equation number 1, okay, x plus dx and y plus dy. So basically the scaling is 1, so it's the same thing that we refer back to the equation number 1. Okay, so this is the example, okay, how the resulting, okay, where we have this triangle shape A, B and C. Okay, we have coordinate of A, okay, x 1 1, B 0 0 and C 2 0. Okay, so all this point is translated by dx plus 2 and dy plus 5. So what we have to do for each of the coordinate, we just plus each of them by this 2 and 5. Okay, so for the A example, for example, the coordinate is 1 1. Okay, so 1 plus by 2 is become 3. Okay, so from this point if move to 3. Okay, for the y coordinates is plus by 5. Okay, so from 1 is plus by 5 become 6. So it's move 2 point here, 1 2 for the x direction, and for the y direction 5, 1 2 3 4 5. So become 6. Okay, this is the example. So the point B and C also the same. Okay, when you move the x direction by 2 and y direction by 5, so everything will move here lah. Okay, this is the new position of this triangle lah. It's become A dash, B dash and C dash. Okay, so this is the animation of translation, okay, where we can see this house is still in shape but at a different position only. Okay, it's not become bigger or smaller, also it's not rotating, it's just a movement around this axis. Okay, so that's for the translation. Okay, the second one is on the scaling. Okay, the 2D scaling. Scaling a coordinate means you multiply each of its component by a scalar. Okay, uniform scaling, which mean that you have a same scalar for both x and y. For example, x multiplied by 2 and y multiplied by 2. Okay, the non-uniform scaling is in the different scalar. Okay, for the different components. For example, 2 and 3. So x multiplied by 2, y multiplied by 3. Okay, so this is you call non-uniform. Okay, so for the scaling with the respect of the origin, which mean that is from the point of 0 0. Okay, or it can be a point of origin of the what is the coordinate of A, B and C, for example. Okay. Okay, if scale value is bigger than 1, so the object is basically moved away from the origin. Okay, while where the value is below than 1, is the object is moved toward the origin. Okay, toward the 0 0 points. Okay, so this is the equation, the next equation number 2 that you have to remember for the scaling. Okay, the x dash, where x the origin coordinates directly multiplied by the scale. Okay, for example, if the x is 1 and is the scale for x is 2, so the x dash become 2. Okay, so same for the y dash. If the original value of y is 1, is scaled by 3, so it's become 3 lah. It's direct multiplication. It's very easy. Okay, so this is in terms of coordinate. Okay, where you can have a in terms of matrix form. Okay, so the x dash is a new x coordinate and y dash is a new y coordinate lah. Okay, the same thing that we have learned before. For the translation, so the x scale is the scaling factor and y scale is the scaling factor for y. Okay, x and y respectively. Okay, in terms of metric form, okay, this is the, you can show like this, where x scale, okay, multiplied by x, okay, and 0 multiplied by y, so become 0 lah. So that's why it's become like this. x only multiplied by x square, because on the y there is a 0 value. Okay, for the y also the same. Okay, 0 multiplied by x, so the x will no value of x, only y multiplied by y scale. Okay, so we will get the previous equation of equation number 2 lah. Okay, it's a direct forward multiplication. It's a simple. Okay, so this is example. Okay, where the same triangle. Okay, we use a, b and c, where we have the point a. Okay, 1 1. Okay, we multiply 1. Okay, the movement is 2 and 5. 1 multiplied by 2, so it's become 2 here. Okay, okay, 1 multiplied by 2, so it's moved from 1 to 2. And then for the y, is multiplied by 5. Okay, from 1 going to 5, so the new coordinate will be 2 5. Okay, so for the b, 0 0, so multiply by 2 and 5, it's become 0 0 lah. It's not move anywhere. Okay, the b dash also here. Okay, for the c, 2 multiplied by 2 become 4. Okay, and the y coordinate 0 multiplied by 5 becomes 0 lah. So for the scaling of 2 5, from this shape is become like this, bigger. Okay, so that's the same thing lah when you want to scale your product design. Okay, you have you can make it bigger. So this is basically the metrics that involve behind the CATIA or SolidWorks software lah. That's the programming that has been designed in the software. Okay, so scaling, you can see it. Okay, when its scaling factor is bigger than 1, okay, it's moved away from the origin. When the scaling factor is below than 1, it's moved towards the origin position. Okay, there's also that the scaling, this one is the previous one is on the scaling based on its origin point, A, B and C. There's also scaling is based on the center point. Okay, which means that the center point, you will see some of the result like this. Okay, the origin triangle is in the green color. When it's scaled from the center points, okay, it's become the center point of the scale shapes also have the same center points, because they use scale from the center point. So when the question come up, is it when the question asks scaling from the center point, so please be aware, you have to find first the center point, and then whatever the scaling factor is, you must refer to the scale the center points. Also the same like this house. Okay, it's not scaling based on the each coordinate, it's scaling based on the center point. Okay, so both will have a same center points, even though it's smaller or bigger, they are both have the similar center point. Okay, the next one is on the rotational. Okay, the equation is not that complicated lah, basically. Okay, you still can remember this is of course quite simple one. Okay, for the x dash, okay, this equation number 3, x dash is x coordinate multiplied by cos theta minus y coordinate multiplied by sin theta. Okay, while for the y axis, y dash, the resulting x multiplied by sin theta plus y multiplied by cos theta. Okay, so in terms of metric representation, okay, you can see like this, x multiplied by cos, okay, minus y multiplied by sin. Okay, for the y dash, x multiplied by sin, okay, y multiplied by cos. Okay, this is the same thing that you get in question 3 lah. So for this you must consider both, even though it's a movement of the, because it's become rotational, so it's evolve both to exist. Okay, so for each of the value, the resulting x value is contributed by both x and y coordinate. Okay, so the metric of rotation, okay, the rotation is always in the counterclockwise degree lah. Okay, that is the thing that you have learned before. Okay, in your mathematics. Okay, for example here. Okay, so you have a axis. Okay, x and y. So basically, this is the the rotational direction. Okay. Okay, it's 360 degree. Okay, so basically the basic rotational, okay, is always a counterclockwise. Okay, with the respect of the origin, unless it's mentioned by the minus. Okay, rotational. Okay. Okay, so for example, this one, okay, the 2D rotational example is a 25 degree clockwise. Okay, so when it's mentioned 25 degree without clockwise, so basically you must have in your mind, it must be in this movement lah. Okay, 25 degree. Okay, but this one is mentioned as a clockwise, so that it move clockwise 25 degree. Okay, okay, so from this you have to use a minus value. It's not a, because basically when rotational involve a anti-clockwise, when it's mentioned as a clockwise, so you must have to calculate your degree as minus 25 clockwise. Okay, is this the in the equation. Okay, previous equation. Okay, this value of theta you must use a minus. Okay, because it's mentioned clockwise. Okay, so the thing that you have to alert. Okay, okay, so basically when you include this value of a, for example, is a 1.52. Okay, when you include this one, x is 1.5 and y is 2, and all the theta you set as a minus 25, you will get a value of this a minus. Okay, the same thing b and c. Okay, you have to do the same. Okay, okay, so that's basically how the thing works for the rotational. Okay, you can see that the object is rotate like this. Okay, mean that everything is moved around. It's not like a scaling. This house is still in shape, but it's just moved in position. But this one, the roof itself, it also move in rotational. Okay, okay, the final topics for the translation is shearing. Okay, okay, shearing basically involve in term of two movement like the same on the rotational. Shearing involve both x and y. Okay, so this is the metric for the x and this is metric for the y. Okay, so by shearing both metric axis, so this is the matrix form lah. Okay, where it's a combine of these two matrices. Okay, it's become x and y shear like in this position. And this is the final equation that you have to remember, question number 4. Okay, where you have the x dash, the x value plus the x shear. Okay, how many dash is it shear? Is it 2 or minus 2? Okay, depend on the value, and multiply by y. Okay, also for the y dash is y plus y shear multiplied by x. Okay, so this is the equation that you have to remember. Okay, okay, this is for example. Okay, you have this metric, this what we call the triangle. Okay, the same triangle, basically the position of a, is 1 1. Okay, so when you have a share of 1.5 and 0, okay, by using this equation, okay, for example, the x is 1, okay, and x here is 1.5 multiplied by 1, okay, is become 2.5, okay. Okay, this is 1.5 multiplied by 1 is 1.5 plus 1 is become 2.5. Okay, okay, so also goes the same goes to y dash. You can calculate it. Okay, you can confirm it later. Okay, it's will resulting of this shape. It's like sharing lights to the right and to the left. Okay, that's basically the movement of sharing involved two axes. Okay, so this is the animation, and it move to the right and left, okay, by sharing, okay, which means that it involves both axes, okay, and it's moved like this, okay. This is called the sharing movement. Okay, okay, so this is the summary. Okay, the four simple equation, okay, that you have to know. The basic transformation in 2D and 3D. Okay, this is for the 2D, just involve two axes, x and y. Okay, but for the 3D is just a simple, it's just additional of another one axis, which is z axis, and also use the same equation. Okay, okay, the next topic is on the combining transformation. Okay, what I already said before is the before this we learn on the separate translation is involve translation, separate transformation involve translation only, scaling only, okay, or rotation only, or sharing only. But this one is we can combine all together, maybe translation and scaling, or scaling to and rotation. It can become a combination of the movement. Okay, transformation. Okay, so transformation can be combined with the simple algebra. Okay, basic scaling and rotating with the respect to origin. For example, we want to have a scaling and rotating movement together. Okay, to scale or rotate about a fixed point, you must first translate the object to the origin first, so that it's become a fixed point of 0 0. Okay, before you want to do any scale of rotating or rotate scaling and rotating, you must convert like the origin position of 1 1, you must move to 0 0 first, then later you can do the scaling and rotating. We can see the metric form after this. Okay, then we can perform the scaling or rotating, and then we inverse back the original translation to move the fixed point back to the original position. Okay, so this is the example. Okay, when you have, okay, for example, we want to scale the triangle by 2. Okay, 2 in each direction, which the point of origin point is 1.5 and 1. Okay, the first we do a translation by minus 1.5 and 1, so it's become 0. Okay, and then we this is multiply, this is have a bracket here, so we move to the scaling. Okay, and then we plus back with the original point. Okay, so we can have the translation. Okay, we first translate out the point of the triangle by t. Okay, minus 1.5 and minus 1. Okay, like this. Okay, and then we scale it by this 2, and then we translate back with 1.5 and 1. Okay, so this is basically when we involve a combination of transformation, okay, of scaling. For example, okay, we want involve a scaling and rotating. First, we must translate the coordinate become 0 0, and then we do a scaling, for example, and then we do a rotating, and later we translate back to the the original coordinate lah, so that that's the final answer that you get basically. Okay. Okay, so this is the metric composition. Okay, transformation that can be combined by matrix multiplication. Okay, for example, this you want to involve a tree. Okay, uh, transformation. Okay, which a translation, rotation, and scaling. Okay, so what you must to do first is order of the multiplication methods. Okay, you must solve this first. Okay, the translation and rotation first, and then later you have a new matrix here. Then you can do a scaling. Okay, so basically the complicated transformation can be done using the numerical software like MATLAB and Excel. So it's quite hard for the complicated transformation that involve all four together. But you can easily code it using a MATLAB or Excel, and whatever the value you want to change, you just change at the main source, and then all the movement will be calculated automatically lah. Okay. Okay, so for the 3D transformation, okay, is the same one what you have learned before in the 2D transformation, but this one will have a uh, bigger matrix lah. Okay, the same idea as a 2D but using a bigger matrix. Okay, so for the 3D scaling and 3D translation are shown as below lah. Okay, where you have the x dash, y dash, and z dash. Okay, it's a metric of the scale. Okay, and W is the same thing, where you can involve when you scale it to the new position, you can scale it in terms of, is it one you want to maintain the size, or you want become the size become double, or so on lah. Okay, okay, so the next one is on this. Okay, translation. Okay, also the same. Okay, where you have the x dash. Okay, x we plus by tx or dx. Okay, y we plus by ty or dy, and z we plus by dz and or dz. Okay, so that's basically it's the same concept, but there's just an additional of z axis. Okay, for the rotational. Okay, this for the rotational you have to do like this. Okay, this is the metric. Okay, so for the z-axis, when you want to rotate in terms of z-axis, so the z-axis we left it without any value lah, unless which this one value at the z. Okay, so what you have learned basically in static, when you want to move, okay, for example x, y, and z. For example, for the x you see here, okay, so the value of x is only one x-axis, so that it can rotate x. Okay, when y, okay, you have a value of 1 at the second value of y here, so that it can rotate around the y-axis. And also for the z, okay, so the same, you rotate around the z-axis direction, so that you leave the z with only the one value here, so that you can rotate, okay, like that. Okay, so that's basically what you have learned also in static. Okay, okay, so that's the final slide lah basically. But somehow I want to show you. Okay, maybe you have already go through this slide in the e-learning. This is an example of the past year of the question. Okay, on the calculation. It's a simple and direct forward basically, but I think this is like 2 or 3 past year before. Okay, when from the 150 student, okay, during that time the subject is combination of aerospace, mechanical, manufacturing students, so the number of students is quite big. Only 3 students surprisingly can answer both question correct lah. Okay, 1 and 2. Okay, it's of course there are students that do some mistake also, but it's quite surprising also because just 3 out of 150 that can answer it correctly. Okay, so maybe I can show you this example. Okay, so figure 1 shows a 2D triangle. Okay, object that represent by coordinate A10, okay, B20, okay, and C. Okay, maybe you can write here A10, B as a 20, and C 1.5, 2. Okay, so calculate and draw the resulting 2D triangle object of coordinate A dash. Okay, so will be the A dash, what will be the B dash, and what will be the C dash for each of the transformation below. Okay, so maybe we can take the example of number 1. Okay, 2D scaling of sx, okay, equal to 2 and sy equal to 5. Okay, when you do a scaling, mean that you use this equation number 2. Okay, for the x dash, for example, okay, you can directly multiply lah. Okay, for the a dash, you 1 multiply by 2 is become 2, and 0 multiply by 5 is become 0. Okay, so for the y, is a x dash and y dash. Okay, for the point B, okay, 2 and 0, 2 multiplied by 2 is 4, okay, and 0 multiplied by 5 is 0. Okay, so this is x dash and y dash for the B coordinate. For the C, okay, 1.5 multiplied by 2 is 3, and 2 multiplied by 5, okay, sorry, okay, so 2 multiplied by 5 is 10. Okay, so this is basically the answer lah. Okay, where you can plot the new of the scaling position using this coordinate lah, 20 here. Okay, for the A, B 40, okay, you have to draw a little bit here, 40, and 3 10. Okay, 3 here and maybe 10 here. So you will get the answer like this lah. Okay, so 2, okay, this is the answer, 20 here, 40, and 310. This is the resulting scaling. And also the sharing, you can use this equation, okay, and you can do the same, and you can get the sharing position here. Okay, this is sharing based on the each of the point lah. Okay, it's not sharing based on the origin or what lah. Okay, so this is the new shape position that you will get. Okay, basically, okay, so actually it's as simple as that. Okay, so I hope you can clearly understand this. Okay, and can easily answering the test letter. Okay, I think that's all for today class. Okay, enjoy your class, and thank you very much.